Using the previous video as a reference, let's go ahead and practice using the laws of exponents to simplify the given expressions. Don't use negative exponents in your answer because we want to just focus on the process and not worry too much about all the options. We're just going to go with the principal answers. So this first one we have is a power raised to a power. What this means is we can multiply the power to the power higher. So we'll get 64 raised to the 3/4 times 2/3. Notice that my fractions will simplify or reduce, and I have 64 raised to the 2/4. Well, I know that 64 raised to the 2/4 is equal to 1/2. That reduces, that exponent reduces. And 64 raised to the 1/2, well, you could put in your calculator, but hopefully you realize that this is the square root of 64. What number multiplied to itself will give you 64? 8. And so our answer, our principal square root, is 8. Now let's look at B. We have x raised to the 1/4 times x raised to the 1/3. The bases match. When we multiply bases, we add exponents. So this will be x raised to the 3/4 plus 1/3. Notice that we cannot combine these until the denominators match. So I'll build the second one up by 4/4 and the first fraction up by 3/3. This gives me a new statement, x raised to the 9/12 plus 4/12. And I know that if I add those two fractions together, I'll have x raised to the 13/12. Let's take a look at C. We have two bases inside that do not match. They're raised to the 1/2 on the outside, which means we can distribute that power in to both fractional exponents inside. We'll have m raised to the 2/3 times 1/2. The other base is n, and we'll raise that to the -1/4 times 1/2. We can simplify, and m will be to the 1/3 times n raised to the -1/8. Now remember, if you have a negative exponent, that means that your base will shift from the numerator to the denominator, or if it's in the denominator, it should shift to the numerator and become a positive. It changes sign when you change what side of the fraction it's on. So rewriting this, we will have m to the 1/3 over n to the 1/8. This next expression has three bases, all of which do not match each other, and it is all raised to the 3rd power. We can think of 3 as being 3/1 if it helps us with dealing with fractions. We can distribute that 3 to each factor inside parentheses. So x to the -2/3 multiplied to 3/1 as an exponent, times y to the 3/5 multiplied by 3/1, and z raised to the -4/7 times 3/1. That will simplify to x to the -2, y to the 9/5, and z to the -12/7. Notice that I can simplify this further. I'm doing this because I don't want negative exponents. So I'm going to rewrite this as any exponents that are negative as in the denominator. So y to the 9/5 is positive, so that will stay in the numerator. X to the negative 2 becomes x to the positive 2 in the denominator. And z to the negative 12/7 becomes z to the positive 12/7 in the denominator. In this last example, we have a fraction, or rational expression, 4x to the negative 2/3 over 3y, all raised to the third. We can distribute that exponent 3 to both the numerator and denominator. Notice since we have multiple factors in the numerator, we'll have to distribute that exponent 3 to both the 4, the x to the negative 2/3, and in the denominator to the 3 and to the y. Simplifying, we get 64x to the negative 2 over 27y to the third. I can keep simplifying this because we have a negative exponent in the numerator. This means I need to bring this factor down and change the sign. My final answer is 64 over 27 x to the second y to the third.